Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is n meetings in one room. First of all, let us start by understanding the question. What does question say? There is one meeting room in a firm. There are n meetings in the form of start of I and end of I, where start of I is the start time of meeting I and end of time is the finish time of meeting I. So there is only one meeting room in one organization, and there are n meetings to be scheduled, n meetings to be held. The meetings are given in the form of start time and end time of the meeting. What is the maximum number of meetings that can be accommodated in the meeting room when only one meeting can be held in the meeting room at a particular point of time? So what are the maximum number of meetings which we can successfully held? Why? Because there is only one meeting room, and at a time only one meeting can be done in that meeting room. So if multiple meetings have overlapping time, then they couldn't be conducted in the same room at a time. Okay. So if we see what can be the maximum subset of meetings that can be conducted in that room such that there is no overlapping timings. Okay. Start time of one chosen meeting can't be equal to the end time of other chosen meeting. So even the start time and chosen time should also not overlap. Okay. They also can't be equal. For example, if n is equals to 6, the answer is equals to 4. We will look at the explanation later. N equals to 3, here the answer is 1. You don't need to read input or print anything. Complete the function maximum meetings that takes two arrays start and end along with their size n as input parameters and returns the maximum number of meetings that can be held in that room. The expected time complexity is n log n and expected auxiliary space is big O of n. So now if we think about solving this problem, then before moving on to the solution, let us understand the question a little bit better. So there are n meetings which are denoted with the help of the start time and end time of the meeting. And there is only one room in which the meetings can be conducted. So we need to tell the maximum number of meetings that can be conducted in this one room such that at a time there is only one meeting in that room possible. Okay, so the meetings cannot have overlapping timings. So for example, if we take a very simple example, if the number of total meetings is 2 and the start time of a meeting is this and the end time is this, and for another meeting the start time is this and end time is this, then there is this overlapping time. And since we have only one room, at a time we can conduct only one meeting. So both of them cannot be conducted. So either we can conduct this meeting or this meeting, and hence the maximum number of meetings conducted for possible to conduct for this case is 1. So 1 is our answer. So that's the basically the problem. Now first I'll tell you the approach and then I'll tell you the reason behind that. That would be better. So what will be the approach is, out of the remaining meetings to be considered, okay, I'll explain you, you'll get everything. Okay, just hold it. Out of the remaining meetings, we will select the meeting whose end time is minimum, and in this way we will get maximum number of meetings. Now what is the meaning of that? For example, if I draw the meetings in the form of start time and end time on a number line, let's say these are some of the meetings. Okay, okay, let's say these are some of the meetings. So first preference will be given to the meeting which has the least ending time. Now this is ending here, 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 and this is ending here. Which is ending the first? This one. So this will be chosen first. Okay. Now no matter where it was starting, it might be starting from here or from here. But since it has the least ending time, we will select and add it to our answer list. Why do we do so? Because the meeting which ends very early, if it ends early, other meetings will get the chance earlier for that room to conduct the meeting, right? We will also see the kind of mathematical proof, but this is just the intuition behind that. So since this ends the first, so I will select this meeting. So this is my first meeting. Now since this ends here, I can only select the next meeting whose starting time is greater than this. So what are the meetings left? So I think this is the meeting and this is the meeting left. Now among these two meetings, which has the first ending time, we will select that. For example, let's say there was one more meeting here. Okay. Now, so we cannot select this, we cannot select this, we cannot select this, we cannot select this. What is the next meeting with the lowest ending time? These are the three meetings which we can select because their starting time is greater than this. Okay. The last meeting selected ending time. but which has the least ending time, this or this has the least ending time, so I'll select this as the next meeting. Now I will select a meeting whose starting time is after this meeting, because last I conducted this meeting, no, so this will end at this time, so the next meeting to be selected shall have starting time greater than this. Also, can you see here if we had selected this as the second meeting, there was an overlapping time here, so we couldn't have conducted this meeting. Okay, irrespective of whether this was starting year or year, since its ending time was year, we were not able to start the third meet. But because we selected this meeting which ends here, we can also select this meet, okay, and conduct this meet, because this ending time is here and this starting time is here. Now we will select the meetings whose ending time is bigger than this, but there are no meetings, so our answer is 3. Okay, so basically our approach is, first of all, sort the meetings with respect to ending time, then select the first meeting, add it to our answer, and then select the next meeting whose starting time is greater than the ending time of the last selected meeting. And when you select that meeting, then further you will select the meeting whose starting time is greater than the ending time of the last selected meeting, not the first, the last meeting which was added to our answer. So the next meeting which we will select should have a starting time greater than that meeting. Okay, so that would be our approach, and in that way, whatever the maximum number of meetings we could select, that would be our answer. So I gave you an intuition that when the meeting ends earlier, other meetings get a more chance to be conducted. For example, here if we would have selected this meeting which would end here, then this meeting would haven't got the chance, but since we selected this meeting which ends here, this meeting got the chance. Now if we try to see a little bit of mathematical proof behind it is, then how can we say it? Let's say these are the meetings which are in my answer. Okay, this is my answer set where there are 6 meetings. Okay, so 6 is my answer. I selected 6 meetings, and I told that this is the max, these are the starting and end time, okay, on the number line. So this is start time, end time, start time, end time. Obviously it will not have overlapping. Out of total n meetings, this is the maximum 6 size subset of the meetings which can be conducted, which do not have overlapping timing. Suppose, now let's suppose I tell you that this meeting does not have the meeting, does not consider the meeting which ends first. This, let us assume that this does not have meeting which ends first. Now our approach was to select the meeting which ends first, and in that way we told that it will give us the maximum number of meetings. So somehow if we can contradict this statement, then we will prove it. So let us say out of total n meetings, this is the set of meetings, this is the maximum set of meetings which can be conducted successfully, that is 6. And let's suppose it does not contain the meeting which ends first. So if I draw the meeting which ends first, how would it look? Let's say this is your first meeting. Okay, so if I draw the first meeting which ends first, how will it look? See, its ending time should be less than this, obviously, because it ends first. So it would be either something like this or something like this. Are you getting my point? It means its ending point is before the starting point of this meeting. Okay, or it might have an ending point here, but it cannot have ending point after this, because it is the first ending meeting which we have not selected. Okay, let us suppose. So either its ending time could be in between this, or its ending time could be even before the starting time of this meeting, right? Now there are these two cases. In the first case, where its ending time is somewhere between, I can remove this meet and add this meet. Are you getting my point? In the first case, these are my 6 meetings which I have told that this is the maximum set of meetings which can be conducted. If I have not considered the first ending meeting, it could be either here or it could be somewhere here. I mean, its ending time could be even before this, or it could be somewhere here, right? It cannot be after this because it is the first ending meeting. So its ending time must be less than this. So if its ending time is less than this, then I can remove this and add this meeting to my answer set. That will also give me the same number of meetings, that is 6. 1, 2, 3, 4, 5 and 6, right? So that will also give me the optimal answer. But in this case, Here, since the ending time of this meeting is even before the starting time of this meeting, I could even add this meeting to my answer set without removing this. So in this case, the total number of meetings could be 7. Are you getting my point? So not selecting the first ending meet can also result in a disaster. So hence we have proved that the first ending meet will always give us the optimal answer. There may be a case that even without, like if we look at this example, then even if you do not select the first ending meeting, the remaining meetings give you the maximum answer 6, and selecting the first ending meeting will also give you answer 6. So there may be a case where not selecting the first ending meet gives you the optimal answer, but selecting the first ending bit will always give you an optimal answer. For example, here not selecting the first ending bit was not giving you an optimal answer. Hence, we should always select the first ending bit. Okay, so that was the about the first meeting. Now remove them and do the same procedure for the remaining meets. Again, you can prove, let's say there is one more meeting which is ending somewhere here. You can replace it with this. So at every given point of time, you select the first ending meet out of the remaining meets and compare and select a meet whose starting time is greater than the ending time of the last conducted meeting. So this is the basic concept. Now let's look at its actual implementation. So if we look at the actual implementation, so first of all, I need to sort the meetings with respect to ending time. So I have taken a vector in which I have a pair in which I will store all the meetings in the form of ending time and starting time. Okay. Initially I have taken answer as 0. This last variable will store the ending time of the last selected meeting. Okay. First of all, I have inside the vector, I have pushed all the meetings in the form of starting time and ending time. Okay. Now, why I need to do this? I could have already shorted the ending time, but then I would miss the pairing between the starting time and ending time. For example, if the starting time is 3, 4, 7, 8, and 9, and the ending time is 5, 9, 8, 10, and 13. So if I short them, it will become 5, 8, 9, 10, and 13. But I will lose the pairing, which starting time was with respect to which ending time. So that's why I have formed the pairs and then shorted it with respect to ending time. Here, since the first parameter is end of I, this shorting will be done based on end of I. Okay. Then obviously the first ending meeting is always to be selected. So its ending time is what? A of 0 dot first. So I have stored that in last and I have made my answer variable as 1. Now I will traverse through the meetings, and if the starting time of a particular meeting is greater than last, that is the ending time of the last selected meeting, then I will select this meeting. So because it is not overlapping, so I will do answer plus plus, and the new last will become the ending time of this meeting. Because now if this was the first meeting selected, I was selecting a meeting whose starting time is greater than this. Now if I selected this meeting, I need to select a meeting whose starting time is greater than this. So my last variable will be updated to a of I dot first, and finally I'll return the answer variable. The time complexity here would be big O of n log n, because we are sorting the array, and the auxiliary space required here will also be big O of n, because we required this array A. Okay. Now let's submit this code. Okay, so let's submit it. Okay, so we have solved this question successfully. I hope you have understood the solution completely. Thank you.